Okay, so just this induction question. It's a summing with an indices, so we're going to prove true for n equals 1. So the left-hand side will just be 1, because that's what you get if you just add one term. Or you can use the formula for the term, which is 2 to the 1 minus 1, which is 2 to the 0, which is 1. The right-hand side, we get the sum formula, and we just sub 1 into it. 2 minus 1 is 1. Therefore, left-hand side equals right-hand side, therefore it's true for n equals 1. Okay, assume true, n equals k. That would mean that if you added this up to k terms, you get 2k minus 1. And prove for n equals k plus 1. So required to prove that if you add this up to k plus 1 terms, then you'll get 2 to the k plus 1 minus 1. So that sum to k plus 1 is 2 to the k plus 1 minus 1. And the sum to k is 2 to the k minus 1. That's that, and that's what we're required to prove. Okay, so if we look at the left-hand side, we have sum to k plus 1. We can break that up into the sum to k plus tk plus 1. So the actual sum to k, the sum to k plus 1, equals 2 to the k minus 1. And then a term in k plus 1. So this is what n is 2 to the n minus 1. So tk plus 1 would be 2 to the k plus 1 minus 1, which is just 2 to the k. So now if you look at this, put the 2 to the k's together, and you can think of this in a couple of different ways. This is like 2 lots of 2 to the k minus 1, or you could factorise out the 2 to the k and see that it is 2 to the k times 1 plus 1. If you let 2 to the k equals a, it's easier to see as well that that would be a plus a minus 1, which is 2a minus 1. So it's 2 times 2 to the k minus 1. You put it back in. Now, looking at your prize, this is what we're trying to get. And if you look at that, if you add these indices, 1 plus k is k plus 1. So you get 2 to the k plus 1 minus 1, which is equal to the right-hand side, proven. So therefore, by the process of mathematical induction, it's true for n is greater or equal to